Okay, yesterday, some of you had makeup quizzes and makeup tests to make up. There's a few of you still need to do that. We were turning in any of the above type of assignments. You had a couple of reading guides. Some of you turned that in for your attendance yesterday. Some of you still have that to do today. Some of you completed one of three self-checks. So there's 3 labelings on the final exam, so good to know in advance if you know where these items are, so that if you don't, you got a few days to study up before exam day. So that was in the board for you, and if you haven't done that yet, you still have today and tomorrow to do that. And then you have your exam review packet you should be working on. So we did a Kahoot. We're going to do the last topic today, equilibrium. If you haven't finished your reading guide, you're going to do that. If you haven't finished the self-checks, you're going to do that. If you haven't finished your exam review, you're going to do that. So far, we've done chapter 1, chapter 6, and chapter 8. I found one in the chat. My stuff went too fast. Oh, yes. So the yellow marrow, everybody remembers yellow marrow has fat in it. The fat is yellow. But most people forget that it also has red blood cells in various stages of development. So in the red marrow, you just find red cells. In the yellow, you find the blood cells, because that's where the stem cells are for blood. So many different types of white blood cells in various stages of development, as well as the yellow fat. Any others on the exam review, what we've covered so far? I'll talk a little bit more about that on Tuesday. Structural and functional joints. Oh, good one. I had just corrected this on somebody's paper today, so that was a good question. So structural was your cartilaginous, fibrous, and synovial, what they're made up of. In this question, this is asking for functional, which means how much movement they produce. So you'll remember we had synarthrotic, which has no movement. And that would be like a suture in the skull. You had amphiarthrotic, which has some double life, amphi, a little yes, a little no. That would be like your cartilaginous joints that are in the vertebrae discs. And then the diarthrotic is the one that has freely movable joints. So that would be like your synovial joints, like the ball and socket, the hinge, yada, yada. Of your diarthrotic joints, the one that is most movable is the ball and socket. So there is a question about both of these, but I don't believe there's a fibrous joint classification question. Any others on this before I jump into equilibrium? So in the inner ear, Monday we talked about hearing in the cochlea, and today we're talking about equilibrium, which is in the rest of the labyrinth, and specifically the vestibule. So we have 2 types of equilibrium we want to talk about, static and dynamic. So we should be able to identify the difference between the 2, and maybe just knowing static is kind of constant, right? No matter, I think, what form you use the term static in, it's just meaning something is staying constant. And when you say dynamic, you mean something is changing. So in this case, it's like equilibrium, static equilibrium would be non-changing. It's your position in space. With respect to gravity, are you standing upright? Are you on your head? Are you left or right? Are you moving forward or backwards? Whereas dynamic is that change. So it's angular, rotational movement. All right. And then actually, I don't really get too much into the second piece because we're skipping some lab that we typically do. Describe how equilibrium organs help maintain balance. And this would be how like you need to use vision and proprioceptors and your sense of equilibrium in your inner ear. All of those are working together to maintain balance. And I don't so much get into it Like this guy here, he's got proprioceptors. They're in the tendons and they respond to changes in tension. So that's how we recognize when we're a little off, right? If you were standing on one foot, you wobble a little bit, and that's your proprioceptors sending signals. Your eyes are giving you a point of reference. And when that point of reference changes, that's another indicator that we would be like off balance. So proprioceptors, vision, and your inner ear, the fluid moving in your inner ear are all working to recognize your balance and counterbalance to try to fix it. We normally do a lab that involves all of those things, but I thought for the sake of time, I just let you work on the things you need to do to get ready for exams. So I'm skipping that lab this year. So equilibrium, somewhat different than your other special senses in that we're responding to movements of our head, whereas all our other special senses are like responding to stimuli outside of our body. So we're creating our own stimulus, and it's all in response to movement of the head. We looked at that big bony labyrinth, and you had the cochlea for the hearing, and then the vestibular, and then the semicircular canal. So the vestibule is really where you're looking at your equilibrium receptors. They are also hair cells, just like the hair cells for hearing. So as indicated before, static equilibrium is more about your position in space. So with respect to gravity, are you upright? Are you on your head? Are you side to side? In the reading guide, I talked about if you were in, like if you were at depths in the water, you aren't responding to gravity because you strive for this neutral buoyancy where you just float in one, and you're not rising and you're not sinking. So if you were neutrally buoyant and you were deep in the ocean, you don't have a point of reference where the ground is. If you're deep in the ocean, you can't see the bottom and you can't see the top. So how does our body know which way is up and which way is down if we don't have a visual point of reference? And that's where we have our, we need our static equilibrium to help us out. Dynamic equilibrium, that's more of your roller coaster and merry-go-rounds and things like that, responding to and detecting changes in your motion. Okay, so so they all have hair cells, whether you're talking about the cochlea, the vestibule, or the semicircular canals. So any of these senses are responding with hair cells. So the hair cells are the sensory cells, the receptors right here. And you remember inside of the bony labyrinth, you have that membranous labyrinth, and inside of that, you have that fluid, endolymph. The movement of the fluid presses on those hair cells. We talked about that with hearing, with the loud noise. The more we press on the hair cells, they can stop coming back up, right? And so you're not able to hear anymore. So they have different things that are pressing on the hair cells. So we had that tectoral membrane with hearing. In this case, you have these calcium stones in your head. So people say, your head is full of rocks. These calcium stones, they're called otoliths. And otoliths will drop in the direction of gravity. So if you're standing on your head, they'll drop away from the hair cells, releasing the pressure. That sends a signal to your brain as to the direction your head is facing. If you were standing on your feet, the otoliths would press directly down on the hair cells. If you were horizontal, they're going to bend the hair cells in one direction or the other, depending on which way you're facing. So the bending of the hair cells creates the action potential, which then sends signals to the vestibular nerve, because we're in the vestibule, to the cerebellum of the brain and tells the brain in which direction are you standing, facing, yada, yada. Okay, so those stones are called otoliths, and they move around in the endolymph in response to gravity where they're going to press on hair cells. And depending on the direction they're pressing, they send signals along the vestibular nerve to the cerebellum of the brain. There's a lot of fun words in the whole ear section. I like to do a little bit more with these when we have more time. So dynamic equilibrium, this is the other one. So here's our semicircular canals. Notice they're very closely associated with the vestibule. So we're going to be looking at the crista ampullaris. See, fun words. And also notice the vestibular nerve has two branches, one going to the cochlea and, one going to the semicircular canals and one going to the vestibule. So blow up this ampulla right here, this enlargement. Here you go. Here's our little hair cells and the flap. We'll blow that up again over here. So again, the movement of the endolymph is going to press on this gelatinous cap. So this is called the cupula, and it acts like a swinging door. So like, you know, you push a door to walk in and you can push it and walk out. Like that kind of a swinging door, it goes both ways. When you turn your head, fluid in your head goes in the opposite direction, fluid of your inner ear, the endolymph, right? So I spin left, the endolymph moves right. So it has a lag, it goes in opposite direction of you. And again, depending on the direction it is pressing on these hair cells, it creates different action potentials, okay? So it can press the hair cells in the crista ampullaris, and that sends signals to the cerebellum of the brain. It continues to move after you've stopped moving, which is why a lot of times you feel like you're still spinning after you get off of a roller coaster, or you still feel like you're on the snowmobile after you've gotten off the snowmobile, because that fluid is still in motion. So it has a little bit of a lag behind it. So for the exam, you really just need to know static is response to gravity. It's your position in space. The key organ, like the organ of Corti for hearing, is the maculae. This structure here is the maculae. Whereas dynamic equilibrium is movement, rotational, and it uses that crista ampullaris. There's not a lot of questions on the equilibrium piece, since we're not actually doing anything with it other than talking about it in class today. Okay, so that is that as far as new topics, and that's the last new topic that we will have. We're not covering taste, and we're not covering smell. Taste is fun when we're in class and we can do it like a taste testing lab. That's fun. You have your exam preps here. Click, click, click. A lot of you are done with those. And then you have the reading guides if you haven't done those yet. I did put in some other study tools, PowerPoints by chapter, practice questions, Quizlet by Cashy of that class. Dan Cashy has like a whole semester Quizlet that he made in preparation for exams one year. That can be good practice. But that's all I have. Here's our schedule for next week, in case you forgot. We don't have school Monday. Tuesday, we will get together in a Zoom. It'll be a short class. You have your typical Wednesday schedule. I'll answer any questions you have and tell you a little bit more about the test. Wednesday, you have 5th and 6th hours. Notice we get to sleep in a little bit. We don't start classes till 8:30. You have an hour and a half for each class and a half hour in between. So you'll have the afternoon off. Thursday, Friday, we get together Friday morning for our test. Probably take you an hour. What questions do you have?